lesson, I'm going to go over how we're going to use all of these trig identities to help us prove some of these trig equations. So essentially, the way I kind of treat these is first I need to have my identities memorized. So you've got the three Pythagorean identities up at the top. We've got our quotient identities, which we've already kind of talked about, tangent, but there's cotangent. You can see it's the reciprocal. And then we have already talked about the reciprocal identities. So we're going to use all that information to help us make one of the sides of the equation look like the other. Okay, so we will have a quiz over these identities before we take a test on this unit. So it'll be something that you will have to have these memorized before we actually sit down and take the big summative test. Now, this is kind of the process that I'm going to go through. I'm going to pick one side. Usually, it's easier to start with the more complex side, and then use my understanding of the identities of algebra to help me try to make it look like the other side of the equation. All right. What I do is kind of a last resort. If I get stuck, right, you're going to find out when you try these on your own. There can be some that are going to require some serious persistence. Like you're going to be like, man, this is super frustrating. I don't know what to do. But at the end of the day, if I get stuck, I try to convert everything to sine and cosine and go from there. All right. So again, just like most things that you're going to do, not just in this class, but in life, the more you try on your own, the more you work through the frustration of not understanding, the easier it will become. So we'll be doing some delta math questions together. But again, it's going to come down to, are you going to put in the time to do those questions? All right, so let's go over a few together. All right, so the first one says to verify that the tangent of theta times the cosine of theta is equal to sine of theta. All right, so what I do is I pick a side. The left side has tangent and cosine multiplied together. So I'm going to choose those trig functions to try to manipulate them, rewrite them using my identities to make them look like just sine theta. All right. So I'll do my best here. It's not going to be perfect. Try to show kind of everything my brain is thinking. But 9 times out of 10, when I see tangent of theta, I'll be using the understanding that tangent is the same as sine over cosine. So I'll write sine of theta over cosine of theta times cosine of theta. And one thing I'm going to try this year that I haven't really done in the past is to the side in a different color, I'm going to put the identity that I used. So tangent of theta equals sine of theta over cosine of theta. Okay? So that can hopefully, when you check your work, you can see like why, where did I get that? It didn't just pop magically into my head, right? I know this identity. Okay? Remember, ultimately, at the end of the day, I'm trying to get this. So I'm still not there yet. So I'm going to rewrite it, and I'm going to put a 1 underneath cosine theta. And maybe you'll see that when we multiply, we actually can cross out diagonally. And when we cross out diagonally, the cosine thetas will cross out and make 1. So now I have sine of theta over 1, which is just the sine of theta. Remember, I wanted it to be equal to sine of theta. So really this question came down to understanding this one identity, right, which is the tangent of theta equals the sine of theta, one of our quotient identities. Let's try another one. It says verify the identity cosecant of theta, cosine of theta, tangent of theta is the same as 1. I think this one is pretty simple to decide which side you're going to use to manipulate. You're not going to use 1. All right, you're going to use the one that has 3 different trig functions. So I'm going to first change cosecant to be the reciprocal of that, which is 1 over sine. So I'm going to write 1 over sine of theta. And I'm going to go ahead and just put these as their own fractions. All right, and again, I'm going to show a different color. So what I used was cosecant theta is the same as 1 over sine of theta, one of our reciprocal identities, right? We've been working with reciprocals for a while now. All right, I'm going to put the cosine and sine together, right? Cosine theta times 1 is cosine theta. sine of theta times 1 is sine of theta. All right, and then I'm going to rewrite tangent of theta as sine of theta over cosine of theta, which is actually the same quotient identity that I used on the previous one. So tangent of theta equals sine of theta over cosine of theta. Okay, now at this point, you should notice that if I just look diagonally, I'm actually able to cross out everything, right? Cosine divided by cosine is 1. Sine divided by sine theta is 1. So that's why this is just 1 equals 1. So we were able to get 1 in the end. Okay, let's do the same thing here, all right? Now, this is going to be a little trickier, all right? But when I look at this one, I look in the numerator and I see secant squared theta and the number -1. All right, so one of my identities, right, from the first page is a Pythagorean identity right here that says 1 plus tangent squared theta equals secant squared theta. So let me do a little work to the side. I'll use my different color to show you what I'm doing here. So 1 plus tangent squared theta equals secant squared theta. All right, now that I don't have that, but if you look in the numerator, you can see that I'm one algebraic move away from actually having that. So if I subtract 1 from both sides, then I have tangent squared theta equals secant squared theta minus 1, which is what I have in my numerator. So I am going to replace, right, I'll highlight here, I'm going to replace secant squared theta with tangent squared theta. So I'm going to write down tangent squared theta over secant squared theta. All right, so this was the work that I used for that numerator, changing it to tangent squared. All right, let's go and split that up. Tangent squared theta over 1 divided by secant squared theta over 1. I think we're okay with that. Then I'm going to think back to middle school, and when I divide a fraction, I actually multiply by the reciprocal. All right. Now, I know it says squared, but one of the nice things about these quotient identities and even the reciprocal identities is that if this just says squared, then you just have to change the sign to be squared and the cosine to be squared. So as long as you throw the squares on all of the trig functions, then it's okay. Like, for example, sine squared theta is 1 over cosecant squared theta. So that's what I'll be using to rewrite this first one. So tangent squared theta, I'm going to rewrite as, sine squared theta over cosine squared theta. So let's put that here. And then I'll use my different color to show you what I just did. So I just did tangent squared theta equals sine squared theta over cosine squared theta. And then if I want to rewrite 1 over secant, right, I know the reciprocal of secant is cosine, and 1 over secant is actually cosine. So it's actually cosine squared theta on top. So it's up to you on how you write this. You could write 1 over secant squared theta equals cosine squared theta, or you could write cosine squared theta equals 1 over secant squared theta. I don't care the order as long as you know that they are reciprocals. And then at this point, you should see that we're now able to cross out, right? Look diagonally. Cosine squared theta will make 1. So my answer is just sine squared theta. I know it's a long problem, but if you look, that is what I wanted in the end. I wanted sine squared theta. Okay, I'm hoping that after this one, first off, thanks for watching the video. But if you made it this far and you watched me do that one, your first thought is probably like, whoa, that's a lot. And guys, it is, right? I'm not going to lie to you and say this is simple stuff. This is challenging stuff. It's almost like I don't really play chess because when I was a kid, it was very challenging and my dad would just crush me. And I was like, yeah, this isn't really for me. But when I do these, I kind of think of it as like chess. Like I'm about to make a move, but I do my best to be like, okay, after I make this move, what's coming next? am I able to kind of see a couple moves ahead? And when you start, there's no way you'll be able to see. So really, this is just going to be give it your best shot. And if you get stuck, erase and start over or go back to where you feel confident. You just got to try. There's no substitute for you just trying to do these on your own. Okay? All right, let's try this next one here. It says show that cotangent of theta divided by cosecant theta is equal to cosine theta. Lots of C's here. All right. I'm going to choose the left side to manipulate to look like the right because it's got two trig functions being divided. And I'm going to split those up. So cotangent of theta over 1 divided by cosecant of theta over 1. All right. Remember, go back to middle school, multiply by the reciprocal. All right. When in doubt, if you're like, I don't know what to do, nothing crosses out, always convert things to be in sine and cosine. So we've used twice now, maybe even 3 times. We've used the quotient identity tangent of theta equals sine over cosine. But the other quotient identity up here is the cotangent of theta equals cosine of theta over sine of theta. So that's what I'm going to use to rewrite cotangent. I'm going to write this as cosine theta over sine of theta. And I'm going to put my work here. Actually, let me first copy this down. All right, choose a different color to show you what I did. So I use cotangent of theta equals cosine theta over sine of theta. Okay, still unable to cross out, but I notice I see cosecant, which is a reciprocal of sine. So copy down cosine of theta over sine of theta, and times 1 over cosecant of theta is actually sine theta. All right, so that one I used. Again, kind of like the last one, I don't care the order that you write it. So I'll change the order this time to see if we're okay with it. So sine of theta equals 1 over cosecant of theta. Okay? Now if I look to my diagonals here as I multiply, I can cross out sine of theta over sine of theta and just end up with cosine of theta, which is the right-hand side. That's what I wanted. Now, I will say, as you start to do these, and especially when they're really tough and there's a lot of work involved, the the joy that I feel when I get one of these right is amazing. I really enjoy it. So hopefully that's you. If not, do your best. Okay, let's try this one. All right, got a lot of room here. So it says verify the sine squared theta minus 1 over tangent of theta times sine of theta minus tangent of theta equals sine of theta plus 1 over tangent of theta. Now, you can make an argument for either side, right? Both look pretty confusing, but I would argue that the left side looks a little bit more complicated. You've got a sine squared on top, and you've got not just tangent of theta in the bottom, you've got tangent of theta times sine of theta minus tangent of theta. So I actually am going to choose the left side to look like the right side. Now, the first thing I notice in the top, right, is that this is the difference of two squares, right? The sine squared theta, I know it's kind of weird to say it, right? You can think of it as like x squared minus 1. And you guys hopefully know how to factor that from last semester or even algebra 2, right? So that's how that factors. But obviously it's not x squared minus 1. It's sine squared theta minus 1. So I'm going to factor out this to be the difference of two squares. So sine of theta minus 1 times sine theta plus 1. All right, and so I'm going to write down, let me copy down the denominator first. So tangent of theta times the sine of theta minus tangent of theta. So in my, my algebra work that I did here was I did dots. All right, which is exciting. Now, the numerator is going to stay how it is, but I'm going to factor out something in common in the denominator. And if you look in the denominator, you should notice that we have tangent in both terms. So I'm going to factor out tangent of theta, right? And then when I divide tangent of theta from both those terms, I'm left with sine of theta, and then minus tangent of theta divided by tangent of theta is actually minus 1. All right, so I'll put my work here is factor out tangent of theta. Okay? So now at this point, I'll notice that I can cross out something, right? I can cross out sine of theta minus 1 and sine of theta minus 1 at the top and the bottom. And I'm left with just sine of theta plus 1 over the tangent of theta, which, if you notice, that is what I want. I want sine of theta plus 1 over the tangent of theta. So we were actually able to get there without actually having to use any trig identities, right? We didn't have to use any Pythagorean identities. We didn't use any reciprocal or quotient identities. We just used algebra, right? Which I know is like, seems kind of unfair to all of a sudden just throw this algebra back at you, but that's the deal. You got to be solid with your algebra, even as we're making our way through the world of trig. Okay.